Today's lesson is about how we use BIDMAS within the context of fractions. So it's going to be quite a challenge this, but we're going to have a go anyway. So you'll see that I've got two calculations, two examples I'm going to go through, and we're going to look at how we apply the laws of BIDMAS to fractions, because the laws of BIDMAS apply to pretty much every calculation that we ever do. So BIDMAS again stands for brackets, then indices, division, multiplication, addition and subtraction. And so when we've got a calculation that has more than one of these operations, we have to follow these rules. So for the first example, if you look, we've got 2/3 plus 5/7 times 1/3. And so because we've got addition and multiplication in there, the multiplication aspect is the bit we're going to do first. And so directly underneath that calculation, I'm going to write out the multiplication of that. And remember our rules of multiplication with fractions, we times across the tops and we times across the bottoms. But before we do that, we should always check whether the fraction cancels. So we can cancel vertically, and in this case we can't, and we can cancel diagonally. And again, in this case, we can't. And that method only applies for multiplication with fractions. So if we look now, we've got 5 times 1 on the top and we've got 7 times 3 on the bottom, which makes 21. And so I'm just going to write a new line of working. And what's really important when you set out your calculations with BIDMAS and fractions is that you set it up nice and clear. So you can see that directly underneath this calculation, I've got my 5/21s and my 2/3 has stayed where it is. So that's a new line of working. What we're now going to do is we're going to add these two fractions together. Now we could use wigwams, and wigwams are great, but for this particular example, we've got fractions of 21 and fractions of 7. And so what I'm going to do instead here is I'm going to give them both as fractions of 21, because 3 can easily be converted into fractions of 21. So underneath this fraction, I'm going to times that one by 7 on the top and the bottom of the fraction. And that's because if we times the numerator and the denominator by the same value, we get an equivalent fraction. So if you times the top by 7, you get 14. And if you times the bottom by 7, you get 21. And what we can now do is, again, I've written a new line of working. There's my equivalent fraction for 2/3. There's my 5/21 as a fraction. I can now add the two together because they've got a common denominator. So we just add the numerators. 14 add 5 makes 19. And then we do a quick check to see if that can simplify. 19 is a prime number. 21 is not a factor of 19. And so we're fully simplified there. So a quick underline to say that that's our final answer. Okay. This next calculation, even more challenging, because there's lots of kind of hidden stuff within this question that we don't actually see. So we've got 2.5 add 3/5, all divided by 2/3 times 1/4. Now, when you've got the big line like that, the division aspect, what that actually means is you've got to do the whole of the top. So the numerator's got to be calculated, then divided by the whole of the denominator. So it's almost as if there's some imaginary brackets within this calculation. Okay, and that's because the divide line says we're dividing the whole of the top by the whole of the bottom. So what we're now going to do is we're going to do each of them kind of calculations simultaneously. So we've got a mixed fraction there and a mixed fraction there. So before I do anything else, I'm just going to convert them into top-heavy fractions. So 2.5, 2 times 2 is 4, add 1 makes 5. So instead of writing 2.5 on the top, I'm going to write 5/2. And instead of writing 3/5, well, I'm going to leave the 3/5 exactly as it is. It's the 1 1/4 that I'm going to change next. And 1 times 4 is 4, add the 1 makes 5. So that gives me 5/4. So you'll see that all I've done there is I've just converted my mixed fractions into top-heavy fractions, which is really, really important that we do that within any of our calculation methods with fractions. What we're now going to do is we're going to times the fractions. So I'm going to do the top of the fraction, and I'm going to use a wigwam for that. because I've got 5 and 2 as my denominators, which don't really have any common factors other than 1. So if we times across the bottom of our wigwam, we get 5 times 2, which is 10. And then we've got to do 5 times the 5 to the top left, which is 25. The add sign, because there's an add inside the wigwam, and 2 times 3 is 6. And then on the bottom of the fraction, I'm now going to look at simplifying this bottom fraction. Okay, and again, I'm timesing this time. So I look to see if I can cancel vertically, and look to see if I can cancel diagonally, which in this case I can. So there's 1 and 2, because both of them are divisible by 2. And what I can now do is times across the tops. So 1 times 5 is 5, and I can times across the bottom. So 3 times 2 is 6. And so what I now have is a division sum of 2 fractions. I've got here, well, I've got 21 over 10. So, sorry, 31 over 10, my mistake. And I'm dividing that all by 5 over 6. Now you'll notice that I've written this in a slightly different way now, just to kind of apply our rules of KFC, which we looked at on Friday, because I'm dividing one fraction by another now. And the rule on Friday said that if you're doing division with fractions, you keep the first fraction the same. So that stays as 31 over 10. You flip the second fraction over, that was the reciprocal. So that becomes 6 over 5 instead of 5 over 6. And you change the sign to a times. And before we do the timesing now, we check if we can cancel. 31's prime, so I can't cancel there. But I can cancel a little bit with that 10 and that 6. Because they're both even numbers. I can change that to a 5 and that to a 3. And I think that is pretty much all I can do. So the final thing really is to times across the tops. 31 times 3 is 93. And across the bottoms, 5 times 5 is 25. Now that's a good answer, 93 over 25, but it's not a brilliant answer, because we like to leave our answers as mixed fractions once we get to the final answer. And so just to finish off, we're going to look at how many 25s are in 93. So 1 25 is 25, 2 25s are 50, 3 25s are 75, 4 25s are 100. So that's too many. So I've got 3 whole ones, which makes 3 25s are 75. And then I've got 18 left over to go from 75 to 93. So that's 18 over 25. And again, these aren't going to cancel down. So there is my final answer. Okay. That last one was really quite tricky because we literally applied 3 different rules. We applied the addition rule, we applied the multiplication rule, and we applied the division rule. Okay. If you can do them, you're amazing.